Hey guys, I am back with some matrix problems that are commonly seen on the ACT. I've used a broad spectrum of years to create examples in which they have developed these problems. So you can look at them and not be surprised by what you see on the test if they show up on your test day. Keep in mind, we're looking to help young adults who do not have access to help outside of the classroom. So if you would like, share, and subscribe, I would really appreciate it. Let's get on with question number 1. Okay, so notice we've got A, which represents a whole number, multiplied by matrix, and it's equal to a matrix that's got X, Y, and Z in it. And we only have one number there. So the first thing we need to think about is, let me get my pen tip set up. We have A times 2 and 1, 6 and 4. And that's equal to X, Y, 27, and Z. Now notice there's only one number in the result, which is 27. So we need to, first thing we need to do is figure out what A is. And to figure out what A is, we're going to say A times 6 is equal to 27. And A will be equal to 27 divided by 6, which is going to give us 4.5. All right. So now we know what A is, we can figure out what X is, because we want X plus Z. All right. So we can say A times 2 is equal to X. And we're going to substitute 4.5 for A. Multiply that by 2, and that's going to give us 9.0. So X is 9. Same idea for Z. So 4.5 times 4 is equal to Z. 4.5 times 4 is equal to 18. And that's our Z. Last thing to do, X plus Z. So X is 9, Z is 18. 9 and 18 is 27. And that's going to be answer choice D, as in dog. Let's move on. Man, my glasses. Okay, so which of the following matrices is equal to the solution of adding these two together? So all we're going to do is take 9, negative 4, 8, 7. Add it to negative 6, 5, 6, and 4. Yeah. Now we're just going to take each location that pairs up with one another. So we're going to take 9 plus negative 6. That's equal to 3. 8 plus 6. It's equal to 14. Negative 4 plus 5. That's equal to 1. And 7 plus 4. It's equal to 11. So that gives us a resulting matrix of 3, 1, 14, and 11. And that's going to be solution A. On to the next one. Now notice we're multiplying both matrices by whole numbers. So that's the first step we're going to need to do here to get our result. So we're just going to take and say 2, 1, 3, 2, 4 plus 3 times 2, negative 1, 1, negative 2. First step, we're going to multiply. And when we do, we're going to get 2 times 1, that's a 2. 2 times 2 is a 4. 2 times 3 is a 6, and 2 times 4 is an 8. Now, 3 times 2, 6. 3 times 1, 3. 3 times negative 1, negative 3. 3 times negative 2, negative 6. Now we can add them together just like we did just a minute ago. 2 plus 6, 8. 4 plus 3, 7. 6 plus negative 3, 3. And then 8 plus a negative 6. It's going to be a 2. So our resulting matrices is going to be 8, 7, 3, 2. And that's going to be answer choice G. All right. This is a determinant, and there's a formula for finding the determinant, and I'm going to list it here for you. So in this case, we have 4 numbers, so we're going to say A, B, C, and D. That's going to be equal to saying A times D minus B times C. There's our formula. Notice what our numbers are: 8, 3, negative 5, negative 2. Now they all correspond to our A, B, C, and D in that order. So we got A and D. So we have 8 times a negative 2 minus 3 times a negative 5. So 8 times negative 2, negative 16. Now negative 3 times negative 5 is plus 15. Negative 16 plus 15 is negative 1. And so our determinant is negative 1. That is answer choice C. Next problem. Okay. They want to know which matrix product is undefined. So this goes back to some theory about the matrices and how they're set up. So remember, we always list the rows in columns first. So it's always in this setup: row first and then column. Row and then column. Always. So I'm going to do an example, and then I'm going to jump straight to the answer, so this won't be prolonged and boring. So we can take F. We're looking for matrix W times X. So W has 2 rows by 2 columns. And X has 2 rows by 2 columns. Now, notice this number and this number are the same. So when those 2 numbers are the same, That means it's defined. So that's not the solution we're looking for. So let's jump to K, X, and Z. So X is 2 rows by 2 columns. And Z is 3 rows by 2 columns. Now look at this number here and this number here. They're not the same. And since they're not the same, that's the one that's undefined. So our answer is K. Hopefully that's very clear for you. Going into the last problem. So here we're taking a column times a row. So we have A, 2A, 3A. One, 0, and -1. So we have a column times a row. Just think of it like this. Take the column, and it's like a machine going over each number. So we're going to multiply each value in the column times 1 in the row. So we're going to A times 1, A, 2A times 1, 2A, 3A times 1, 3A. Now we're going to go to the number 0. A times 0, 0. 2A times 0, 0. 3A times 0 is 0. Now we're done with the first two. Now we got to multiply by -1. A times -1, negative A. 2A times -1, negative 2A. And 3A times -1, negative 3A. Put your brackets around it. And then we have answer choice F. All right. I hope that you see the different perspectives of matrix problems that has been incorporated into the exam over a broad spectrum of years. These should help you not be surprised. Sometimes you can use your calculator on the test, and sometimes they're theoretically based. You need to understand both perspectives. That's why I put both types of problems in there. With that in mind, I know the ACT or the SAT is coming up very soon in the next week or so. I wish you all the best. Please remember to stay focused on your studies until exam day. And when you go into exam day, keep your mind focused on the test. Do not allow the timing to be distractive to you. Stay focused on the test. And once it's done, get up, leave, and forget about it. If you have to take it again, take it again. Don't worry about it. All the best.